Do you hear me? Do you hear me well? I'm wearing a shirt to trigger all those biases, you know. Okay, so hello everyone. What I'll be talking about in this presentation is I'll be trying to answer the question from the title. How far is Nebotičnik? So let's find out. I'm going to Google Maps, searching for Nebotičnik. Google Maps figures out our geolocation. We click navigate, and there is our answer. It's 4.2 kilometers. Easy. So from here to Nebotičnik, walking is 4.2 kilometers. Okay, so I hope this was interesting. Thank you for coming to my presentation. All right, but thank you for coming to my presentation is something that I would probably say if I knew that, if I didn't know that I can walk behind IKEA here to make up for all this road through Szmartyńska Cesta. Also, I don't know about you, but is really going through Szmartyńska Cesta the fastest way? I wouldn't probably take it, but maybe. Let's find out. So let me start again. Hello, everyone. On this presentation, I'll be trying to answer the question from the title. How far is Nebotičnik? I'll take you on a whole journey through the technical and through the practical. There will be a handful of jokes. There will be a paradox. And in the end, I hope to show you a solution. I will show you a solution that I hope you will like. Okay? So let's go. Let's define the problem first. Few assumptions for our situation here. Where we'll be trying to get from is our beautiful office on Gruszka ulica. Where we'll be trying to get to is Nebotičnik on Stefanova ulica. And I know the addresses are not the official ones, but this is where the doors to the building are. Yeah, how we want to get to there is by walking, because if you want to drive to that place, there is already plenty of good solutions of how to exactly get there, but we try to walk there. And just because, just to be clear, because we can come up with any length of the path to there, we are trying to find the shortest possible path. Okay, so just to sum this all up, we're trying to find the shortest possible path from Treton 37 to Nebotičnik. Okay, good. But before we try to get to a solution, maybe let's answer what's not so practical about Google Maps. For one, let me get back to this example again. I'm zooming in on the blue line, which is there in the middle of the street. Perfect. So I zoom in a little more, and it turns out I'm navigated as a pedestrian through the middle of the street. I shouldn't be going here, you know, and you shouldn't take that path either. It's just about safety. We shouldn't be walking here. So that's one thing. Yeah, you shouldn't be walking here. Anyway, safety is not the only concern that we might have when navigating with Google Maps. And other reasons speak mostly to our assumption that we want to look for the shortest possible path. And there is, you know, if you look at the city, the urban area is a very complex problem to figure out. So before trying to solve it, let's analyze it a little bit. Like this situation. Where should I go in this situation? There is a perfectly good pavement on the right, right? There is a frequented path on the, there is a pavement on the left, and there is a frequented path on the right. Which one is the best to take? Which one is the shortest one? I don't really know. Will Google Maps tell you that? No, not really. Which is the fastest way here? Is it on the right side of the Platz? Maybe it's on the left side of this Platz. Again, you won't find it in your navigation application. Next situation. Where would a local citizen go in this situation? And also, where would like a tourist that's never been to the place navigate this neighborhood? Who can tell me what is not so great about this path, about this navigation? Anyone? It's about this path. Why not to take the obvious path through the park here instead of going around? That's also a path I took from Google Maps. Another one. Everybody is crossing here. Everybody is crossing through the street. There is no pedestrian crossing. We just are supposed to get there. Everybody knows that. Local citizens know that, but that's also not where we are navigated. Oh yeah, and there's this. So many bridges to choose from. And this block, some of you are familiar. It's not been there last year. There was a long path through the grass. So as you can see, the urban area is a very complicated place, and figuring it all out can be really difficult. But if done well, we can probably shave a lot from this 4.2 kilometers. So how would we go about this? Or maybe before, again, looking for the solution, let's try to answer why it's not really possible to find out in the current setup. I'll be simplifying a lot, but at the heart of the current solutions for navigating are graphs. So let's say in this graph, the green nodes are the crossroads, and the edges between them in this graph are streets. Every street has a bunch of properties connected to them, like a name of the street or the length of the street. And then we apply some graph traversal algorithm on this particular example, and we find out there is our 4.2 kilometers. Quite straightforward, very useful because we use it all the time, but not so great for pedestrians. And why is this? Because using this graph, you won't really find if that's a better way to take the left side of the street or the right side of the street. Yeah, life-changing choices. We also want to get this path through the park here. We won't be able to cut a corner. And do you know how we sometimes take lunches at IKEA and we go through this Ahala? You won't find this path on Google Maps. Okay, so again, before a solution, a quick quiz for you to take. We can divide the city of Ljubljana, at least the center of it, into two parts. The northern part, which is to the north of the railway tracks, and the one to the south of the railway tracks. It happens to be that the place we want to get from is on the northern part, and the place we want to get to is on the southern part. So no matter which the shortest way you would take, you have to cross the railway tracks somewhere. And you do this by one of those underpasses under the railway. There is a underpass on Dunajska Cesta. There is the very scary one next to Situla. There is also this one very popular, like a one-way street with their own traffic lights. The next one, D, is next to a school and it's only for pedestrians. So keep that in mind. And there is also a very solid underpass on Kajuchowa Cesta. Ulica. So the quiz is as follows. If we're to take the shortest path from Treton 37 office to Nebotičnik, which path do you think we should take? You can speak it out loud, or you can just think about it for a while and keep it for yourself. We'll be trying to answer the question at the end. I hear C many times. Was that? If it says it's not on the map, what is not on the map? Oh, this one. Yeah. The one number F is the one underneath the railway station. So you would take that. Okay. Let's find out later. So finally, looking for a solution. So if the graph model doesn't really work well, maybe we should think of this space that we're trying to navigate as a continuous space, not really a graph, a graph like network of streets. Do you know how they say that the shortest path between the 2 points is a straight line that connects them? Let's look at this example. So you want to get from the point A to the point B, taking the shortest path. So this will be the path, the green one. For the ease of calculations, let's say it's 22.6 kilometers. And I have this very simple grid around it, which is a square, and the side of the square is 16 kilometers. So far, so good. If we go with the green line, it's the shortest path. But obviously, if we try to go around, we make it into 32 kilometers. But what if our grid was a little bit denser? Yeah, this would be the path, right? What if our grid was a little bit denser and you would take path as such? We would go 8 kilometers plus 8 kilometers plus 8 kilometers and plus 8 kilometers. Still 32 kilometers, still not even close to the 22.6. What about this one? Denser grid, 4 kilometers plus 4 plus 4 plus 4 plus 4 plus 4 plus 4 plus 4, still 32 kilometers. I really hope that you see where this is going, because, yeah, making those slides becomes ridiculously hard. But even at this point, it's still 32 kilometers, and we are already quite close to the green line, which is 22.6. So, yeah, that's first of our paradoxes. We can get infinitely close to the green line, and using that rectangular square grid will still leave us with 32 kilometers. That's a paradox I won't be diving in for the sake of time, mostly. But it's definitely something worth keeping in mind. The point here is maybe the square grid is not the best grid to take. There is other reasons why we shouldn't take square grids. Let's imagine you want to cover the whole globe, whole Earth, in squares, right? The closer you're getting to the poles, on Antarctica, the squares get more and more disturbed, disformed, and we don't want that. This green is supposed to be square. It's not a square. And as much as I would like to use this kind of grid to cover our streets, and it's also not so easy to use for the calculations. So, have you ever heard this phrase that hexagon is the bestagon? Hexagon is the bestagon. If you missed this piece of culture, I'm leaving a link here to it. But basically, in many places in nature, mostly in nature, hexagon becomes very useful. Whether it's about how bees build their hives, or how our retina in the eye is constructed. Yeah, hexagon turns out to be a very good shape to efficiently cover space. For our situation, it's also good for one more reason. Because from one hexagon to the next one, there is always the same distance. It doesn't matter which direction. It's not the same for squares. So that's perfect. I know this slide is really hard to look at, so let me switch. Hexagons are also very useful when making video games. I hope some of you recognize this one. Exactly for that reason, because the distance from one hex to the next hex is always the same length. Okay, so what's the plan here? We have those hexes. What do we do? The plan is as follows. We take a given space, like a neighborhood, or maybe a whole city. We divide it into a hexagonal grid. Now let's assume that we know which hexes we can walk through and which hexes we cannot walk through. And using some graph traverse algorithm, again, like A star, we can probably easily plot the optimal path through this neighborhood. Perfect. Sounds like a plan. But you may recall that I glimpsed over a phrase which does a lot of heavy lifting here, which is we know where we can walk, but where can we actually walk, right? This is a lot of data that we actually don't have. And what can we do about this? Initially, there is a bunch of good ideas that some of them are more stupid than others. But in general, we have to get the data somehow. Like first silly idea, maybe the data. First silly idea, maybe let's take a bunch of GPS receivers and try to walk on every street in the city, right? But I think we can be much smarter than this. What can we do is take and analyze the public data, like the data from satellite pictures, or the data from services like Strava or Garmin, or the topography data from Open Maps. By analyzing all this data and combining into like one source, we can get a very extensive source for what we need, and it's very practical. So that's exactly what I did. I wore a bunch of GPS receivers and went and tried to visit every street in the city. Does this cyclist look like a regular cyclist? No, because for one, he has 3 legs. But also the guy this one is trying to represent, which is me, is different in more ways. One, he was really annoying to people on the sidewalks for some time. But also he has a bunch of GPS receivers. One receiver is in the sports watch, the other one is in the smartphone, and the most potent one, backpack, large antenna, to get a very good signal. Okay, so seems like a good potential solution. What is the plan? The plan is also to use this. I don't know if this will play. I hope. Yeah, it does. There is a Wikipedia page about, it is a listing of every street in Ljubljana, which might be very helpful. A checklist, sort of to-do list if you're a masochist. So again, the plan is as follows. Go with a bike to Abramova ulica, slowly on the sidewalks. Then get off your bike, walk the streets on both sides, and go to the next one. And by the time you're on Pančićeva ulica, done. Perfect. That's we collected all the data that we need. But obviously, you quickly realize that there is just a lot of data. Streets, rather. 1,538 to be exact, and that's a lot of streets. So that's not very practical. What we can do about it? You know how they say that it's not the destination that matters, but all the streets that you meet along the way? This is something like that. If you use the list from the Wikipedia as just your general directions checklist, you can complete and see so many streets on the way when you're going to that particular direction. We're going to Abramova ulica, but in order to do so, we're traversing all those on the way. Very nice. So you might ask, how did I do? I managed to visit every A street and every B street, at least within the ring of our city. But that was a lot of data still. Is it enough? I don't really know. Let's find out. But I also hear you thinking, because I always hear people thinking, Wiktor, the GPS receivers, the data that comes from them, it's not very precise, especially in urban areas. And you definitely would be right. But there is also a solution to it. Let's say, again, you're going from A to B and recording a track all over the way. It's okay. It's not very precise, but also not so bad. But it's also very, how to call it? It's very imprecise in many spots. A way to solve this is to walk this path again and again and again. And the more times you walk, then when trying to translate those data into a hexagonal grid, you end up with something like this. Eventually, the most visited grid tiles are coming closer and closer to the real situation of where the street or path actually is. What we also end up with is not only whether the tile is walkable or not walkable, but it's also like a spectrum, a weighted spectrum of how probable is that that's walkable. It also shows us what's the habits of the local pedestrians. Maybe which way they walk, what's the most common path that they take, which can come very useful at the end. It adds to our functionality, right? We can now lead others to places that are actually taken by the locals and not some obscure holes in the wall. Okay, so we have gathered some data. We put this into our little hexagonal tiles. But there is more challenges, of course, as you can predict. I'll guide you through this implementation, at least in general, but there is a lot details. So if you have any questions or you would be interested in some particular part, I really invite you to come and talk after the presentation to maybe explain that a little more. But let's go through this at least generally. It all starts with the data. Once you extract your data from all the devices, you end up with a bunch of .gpx files, which unfortunately vary between the providers. But one thing that they have in common is the geolocation data. So we want to extract that and put it in one place. For this step, it suffices. One particular interesting thing that might come as obvious about this data is this is actually data where you can indeed walk. Excuse me, because indeed I've been to those places. Great, but for the ease of use of that data, we should do something else, right? What would be our data structure for keeping this? Because this is, again, not very practical. I found this obscure library. It's a C++ library used by other libraries too, which is mostly used. Yeah, if you're maybe a data scientist, this is not so obscure for you, but for me it is. So libraries like digigrid are using the digigrid library to do those visualizations, data binning, and stuff like this. How this works is it starts with this little three-dimensional shape that I forgot the name of. And it can divide the sphere into more and more dense hexagons. And this is perfect because we can kind of regulate how exact we want to be. Okay, so with this in mind, we are transferring our geolocation data to those IDs of particular tiles. But now, if you consider the city of Ljubljana and surroundings, and you consider that each tile represents a hex that is maybe 2 meters across, that's a lot of data. And as much as many of us would be able to maybe hand-roll an A-star algorithm to go and traverse this looking for a path, the data structure is something that keeps us back from solving this efficiently. So my approach here was to make use of the Neo4j database, which is again a graph database, which you then connect all those previous numbers into. And along with this powerful system that has already looking for the shortest path built in its queries, we can get a very powerful solution. Combining all, this is one of the early screenshots of a graph from Neo4j. Imagine all of those dots are like a hex of 2 meters across. So navigating all this with our homemade algorithm may be just tricky. Again, combining all this gives us a very powerful navigation service. So from this point, it's mostly about making a UI for this, maybe doing some additional plumbing to connect all of the services. It's about putting a few Dockers here, a few Dockers there. And in the end, you are, at least I did, end up with, yes, here it is. Kako, daleč, Nebotičnik. So that's at least this version of the solution. But what is really going on here? Let me refresh so it shows you the whole experience. What's going on here is we go into the app where we agree for it to look up our actual geolocation, and it tries to calculate how long this is from here this is where our office would be, to here where the Nebotičnik would be, and gives a good estimate of how within the data that's already in the system, how far the Nebotičnik is. So the value is 4.01 kilometers. I would say it's saving 200 meters for our walk from here to Nebotičnik. You could argue if it's a lot or not of a save. I honestly was expecting something more, but maybe it's just about the amount of data, because to make things clear, it's only as good as the amount of data that we put in. But also those 3 hexagons, I know this is not very impressive. Let's go in a little deeper. This is a Nebotičnik. Good. We can see what's in there here too. It shows you the grid in a little bit more, with a little more precision. You can see what we are passing and how. There is a few locations that I have already added. So there is, for example, all those things that I don't see name of. Okay, so we're starting, unfortunately, at the edge of one of our larger hexagons. We start from our office going here, and we pass the Kristalna Palacza. Great, I think it's starting to work. And next on the way is this place, which I forgot what it is, Szmartyński Park. Yeah, so it's probably guiding us through Szmartyńska Cesta anyway. So apparently this was a good choice. And the next final hex shows us that we are going next to Żelezniczka Postaja. So it was apparently right. That's the winning solution. We go underneath the passage, underneath the main railway station. Good. What else can I tell you? One thing like this. We see this visualization, right? But actually the hexes here represent about 50 meters of the actual space. So that's not that precise. But the calculation that is going on behind the scenes that shows us this 4.07 kilometers, this is done on a much more precise scale on the hexes that are about 2 meters across. So just so you know, it's just very hard to visualize that, right? You would have to have very tiny hexes. I hope to find a way to do that, but it's not there just yet. It's the URL for this is still not public. I hope to send you a link for this next week, and then I will invite you, of course, to check how far Nebotičnik is from your particular location whenever you are, and maybe compare it with Google Maps and how much basically walking can you save. Okay, and after doing all this, after playing for a bit with the application, let's maybe pause for a second and try to ask ourselves what all that could mean. First of all, how far the places really are. That's something to ponder. Is Google Maps skewing our perception of where places are, and should we walk to there, or does it take too much time? Because sometimes it may be stopping us from taking a walk to a place, because it's 4 kilometers. I would take it if it was 3. Also, think of this. How complicated is your neighborhood? How easy it is to navigate? I'm sure if you're familiar with this, you know a bunch of very nice shortcuts, but if there was a tourist going through it, how would they navigate that space? Maybe we could walk more. That's maybe better for many reasons. So maybe we can be a little more healthy and emit, a little less CO2. That's also great. And finally, maybe you can answer this question for yourself, or at least check for yourself if you can really walk from anywhere to anywhere. So this slide and those questions, I find them fascinating. So, but now I'm curious about your questions about this project or otherwise. What do you find interesting, or where could I have been cleaner? Because this is the last slide. Thank you very much. Simon, you were first.
Right.
So the first question, of course, what is the coverage looking like for your current data?
Yeah, okay, fair question. I hope you will be surprised how often it does work, but of course it's not perfect. There is much more empty space than there is full space. One thing, if you saw this first beginning larger scale grid, there is about 130 hexagons there. The coverage for this scale is 50%, but when you go much more precise, of course, it decays. But I hope you'll be surprised. Try to use it.
Second question, what would it take to contribute?
What would it take to contribute? I think I have the best answer. How to contribute? Great question. For now, at least today, you probably cannot really, but I hope you will be able just next week. There is two ways. If you are a runner or just for some reason record your walks around the neighborhood in Ljubljana, that's, first of all, this is the best data for that kind of project because it's organic, right? You are a local person, you know where exactly are the best paths to take. So yeah, if you are willing to contribute that, I will be very thankful. And there is the second thing, because you notice there is some of the places, maybe important places, but also niche places already on the map. I would like it to be a much larger repository of places, so there will be a way also of adding places to this. So that's about contributing. Thank you for asking this.
My question is about complexity, so I'm interested in storage or space complexity. So on how many, what's the amount of GPS data that you inputted in? And when you perform a calculation, what is the actual size that you need to search through?
Yeah, okay. So it's hard to give a good, meaningful answer of how much data you have to put in. Like it's 2 kilograms or 500 files. This is like a lot of files, right? But maybe something more meaningful on this tiniest grid, that is 2 meter hexes, there is about close to 1,900,000 singular tiles that are already in the system. So yeah, that can give you a scale. Still, this number is not very large when it comes to Neo4j. It can deal easily with billions of nodes and look for different paths. What's the most compute intensive is where your path is very, very low. When it's within 5-7 kilometers, it's quick enough. But once it gets to some point, it gets exponential. So there's probably some good ways of figuring this out. But if you want to traverse Ljubljana from this end to that end, I would actually have to try. I don't know.
Maybe just one comment. I see great potential with this application with hiking app, like a hiking app.
Yeah.
From what would be the shortest or the best way to go up to the hill?
For that reason, this is roughly the edge of the whole map that it's even considered. I made it larger than Ljubljana specifically to take places like Marnagora into consideration. You're asking what's the... Can you clarify a bit what's the question?
It was just a comment that it would be nice usage for hiking.
Yeah, I guess so. Because if you think about this over time, assuming that a lot of data is streaming in, some places like the one with the new block or some fallen tree are appearing. So taking only the last newest window of data, you can account for that the path may change through the forest. Yeah. So that's a good idea, but it's only as good as the data that is in, of course.
Nice presentation. And I know you mentioned Strava heat maps. Did you get any data from there? And so, yeah.
Very good question. Thank you for asking this. But unless you want to add something else, sorry.
Yeah, that was the first part, and the second part maybe. So the the data you used, is it just the data you collected, or is it also this?
Okay, so 2 questions. Yes, it's mostly only the data. It's actually 100% only the data I collected, because it's also data from running. If you're going for a training in the city, it's also a good way of collecting that. Also, if you just casually walk because of other reasons, right? That's also a good reason. Here on the left is the Strava data, and here on the right is the Garmin data. This is the better case to analyze. In here, Garmin, publishes the data, but it snubs them to streets, right? So it's not very useful. We get streets again. We actually want to get the organic movement. And here, the Strava data is perfect. It works great. I'm very the system is very impressive, and they show organic data as far as I can tell. But this is a raster image, right? So analyzing this and trying to convert it into appropriate geolocations is just something I consider impossible. But maybe. So there is no such thing in here.
Yeah. Maybe one suggestion, because this is a raster image, but the segments and the routes are public, and from those you can actually get the route information, and then that contains the actual coordinates and the GPX file.
Yeah, okay. Probably worth to dig in some more. But there is the question whether it's legal to take that data for your particular use.
Thank you.
And in your example, you only considered distance as a metric, that because sometimes shortest path is not the fastest one.
I see your point. Maybe it's uphill, or maybe it's going through the mud. Yeah, good point. But for now, no such considerations. Only this popularity, but also not very strongly, right? I'm aiming to for only the popular hexes to appear, but it's not feasible for now.
So if you want to distinguish between a popular option or a short option, how do you weigh these options?
Yeah, it's a matter of arriving at some factor, right? Because at the lowest level, each hex has a counter. How many times have you been through here? So you can multiply it, but it has to be done, organically, and you have to experiment what works, what doesn't. But you can only do that if you have a lot of data. For now, it's not the case.
Yeah. Also, when I was a kid, in my family, we went from a railway station home by foot, and we never took big, large streets. We just took a parallel street, which was quiet. So I think noise levels are also crucial, like for tourists or for pedestrians. So
Yeah, I would love such a thing too. You can imagine that it works, but again, it all comes to data. But yeah, that's I like that it triggers some imagination. So maybe in the future.
Yep.
Okay, so if there is no further questions, again, thank you very much.